Hello, welcome back to another video of Math Today presented by Drew Didelot. This is our final video about sigma notation. Today we'll be learning how to solve a sigma notation expression with an upper limit of infinity. This may sound crazy, but it'll make much more sense very soon. Let's get into it. Here we have a sigma notation expression with a lower limit of 1, an upper limit of infinity, and a rule of 3 times 1/2 to the n power. As you can see, we would have to find an infinite number of terms because our upper limit is infinity. This is impossible to solve with this method, but I just want to start with a few terms. First, we have 3 times 1/2 to the first, and anything raised to the first power is just itself, so now we just have 3 times 1/2, which this is equal to 3 over 2, or 3/2. So we have our first term, 3/2. Next, we would have 3 times 1/2 to the second, and when we're squaring 1/2, we just multiply the numerator, or we square the numerator and we square the denominator. So 1 squared is 1, and 2 squared is 2. Or no, 2 squared is 4, so we would have 3 times 1/4, which this is equal to 3/4. Sorry if I confused you there. I was confusing myself. So now we have 3/4. Next, we would have 3 times 1/2 to the third. This would just be 3 times 1 over 8, because 2 to the third power is 8. So 3 times 1 over 8, or 3 times 1/8, is equal to 3/8. So with 3/2 plus 3/4 plus 3/8. We will stop here. What do you notice about each term? What happens each time you advance to the next term? The numbers get smaller. If you didn't catch it, let me write these fractions out as decimals. So 3/2 is equal to 1.5, 3/4 is equal to 0.75, and then finally 3/8 is equal to 0.375. As you can see, they get smaller. And the way that these numbers are decreasing is called exponential decay, which we might cover in a future video. Also, I want you to notice our common ratio. In this case, it is 1/2 because each term is half of the one before it. Because our common ratio is between 0 and 1, our solution to this expression is going to converge. This means it will eventually stop and add up to a real number. This also means we can apply a formula to find the solution to this converging expression. The formula, the sum of the geometric sequence, or S, is equal to the first term, a sub 1, divided by 1 minus the common ratio, R, will give us the solution to our converging geometric sequence. So let's apply it. Our first term was 3/2, as we can see here. Sorry if I'm writing small. And we are dividing this by 1 minus our common ratio, and our common ratio was 1/2 as we addressed before, so we're just dividing 3/2 by 1/2 because 1 minus 1/2 is still 1/2. So this is the same thing as 3/2 divided by 1/2, which you can apply the rule to solve dividing fractions, which we diagonally multiply. So 3 times 2, we're multiplying this way, is 6 to get our numerator. And then we multiply this way, 2 times 1 to get our denominator. 2 times 1 is 2. 6 divided by 2 is equal to 3. So 3 is our answer to this converging expression. This makes sense because 1.5 plus 0.75 plus 0.375 is equal to 2.626, which is pretty close to 3. We have successfully found the solution to a sigma notation expression with an upper limit of infinity. This was only possible because our common ratio was between 0 and 1, so mathematical rules say the expression will converge or equal to a real number. Thank you for tuning into Math Today for today. I hope you learned something new. Goodbye.